So now we're going to do system of linear equations. So what is basically mean system of linear equations? So we know that linear equations is what? So suppose we have 2x plus 3y is equal to 5. Now here you see the variables are what? The variables are in here, that is x and y, and the powers or the exponent of x and y is what? It's 1. So once you see an equation in which the powers of the variable or the exponents of the variable is 1, those type of equations are known as linear equations. So this one is a linear equation. Why? Because exponent is equal to exponent of the variables is equal to 1. Now, so suppose we have a system of linear equations. So system of linear equations means we have two linear equations in here. One is a1x plus b1y is equal to d1, and the other one is a2x plus b2y is equal to d2. So these are the two linear equations where the variable is x and y, and this a1, b1, a2, b2, they are known as the coefficients. So a1 is the coefficient of x, b1 is the coefficient of y, and this d1 and d2, they are constants. So this is how we have two linear equations, and those two linear equations gives us system of linear equations. Now we'll be learning how to solve these system of linear equations. Now solving linear equations basically means what? We know that if we are given with two linear equations, we have learned to 3x plus 4y is equal to 7. So if we have two linear equations, if somebody asks me what is the solution of this linear equations, the solution of linear equations basically means you have to find the value of x and y. You have to find the value of x and y, and by using elimination method we can solve this one. So what we'll do, so in here, in the first equation I will multiply with 3, and in the second equation I will multiply with 2. So if I do that, for the first equation it will become 6x plus 9y is equal to 15, and second equation if I multiply with 2, it gets 6x plus 8y is equal to 14. So like this way, if I subtract, those 6x goes away, so this one is y is equal to 1. So like this way you will get the values of x and y. Now this method is known as elimination method. But now we'll be learning to solve these linear equations or finding the values of x and y using matrix method. We're not going to do by elimination method, we're going to do by matrix method. So for matrix method, what we have to do, first thing we need to define three matrices. So what are the three matrices? First one, A. This A is known as the coefficient matrix. This is the coefficient matrix. Now why is it known as coefficient matrix? Because if you look at the elements of A, the elements of A is nothing but the coefficients of x and y. You see a1 and b1, it's the coefficient of the x and y in equation number 1, a1 or b1, and a2 and b2 is the coefficient of x and y in equation number 2. So capital A is a matrix in which all the elements are nothing but coefficient of x and y. Now this capital X, now what does this capital X stands for? This capital X stands for the variable matrix. This is known as variable matrix. So variable matrix means what? This matrix contains the elements which are variables. So here in these two equations, the variables are what? X and y. So that's why you have the variables in here as x and y, the two variables which we have. So that's why it is known as variable matrix. And at the end, the third matrix is known as constant matrix. This one is known as constant matrix. Why it's known as constant matrix? Quite immediately, because the elements of the constant matrix are basically the constants. So here you see the constants are what? The constants are d1 and d2. So B matrix will be d1 and d2. So this is how we define three matrices: coefficient matrix, variable matrix, and constant matrix. Now how can I represent these three, the system of linear equations with these three matrices? So we're going to represent it like this: ax is equal to b, ax is equal to b. This is how we represent. So what is my A? This is my A, the coefficient matrix. And what is x? X, this one is variable matrix, and that is equal to d1 d2. You see a1x plus b1y is equal to d1, a2x plus b2y is equal to d2. So this is how we're gonna express the given two matrices in matrix form by using the three matrices a, x and b. So remember this one, ax is equal to b. That's how we represent system of linear equations in matrix form. Now we're going to learn a method how to solve how to find solution of the system of linear equations. So basically how to find the value of x and y, or how to find the variable matrix. Here you see we already know this equation, that is ax is equal to b. Ax is equal to b. Now to find the value of x and y, what do I need to do? Which matrix will I need to find? So here we have three matrices a, x and b. To find the value of x and y, we need to find the matrix x. Look at here carefully. What is that matrix A? Capital A is my coefficient matrix, that is a1 b1 a2 b2. Then this is the variable matrix, that is x, and this is my constant matrix b. So here we have to find this value x, this matrix x, the variable matrix we need to find. So what do we need to find? X we need to find. So in order to find x, what do I need to do? Now we know one thing, if I have an expression like this, 2x is equal to 4. So if you need to find x, what do? Therefore x is equal to, you take 4 to that side, so you get 4 by 2, and you get the answer as 2. So same here, if I have ax is equal to b, so I need to take a that side. So we have ax is equal to b. So if I take x that side, what happens? It becomes b by a like this. But no, that's not possible. Why? Because we have learned in matrix operation there is no such thing as division of matrix. We have learned addition, subtraction, multiplication, but division of matrix is not possible. So this one is not possible. Then what we are going to do? Then we are going to do is, we know one thing, so we're going to do this one as x is equal to a inverse b. In place of doing b by a, without dividing b with a, we are going to multiply a inverse with b. Now you see here, here you see this one, 2x is equal to 4. So what I'm doing is, 2x is equal to 4, I'm not doing it to be 4 by 2. I'm not doing 4 by 2. What I'm doing is, I'm writing x is equal to 2 inverse 4. 2 inverse into 4. Now 2 inverse means what? It is just 1 by 2. So I'm just multiplying 1 by 2 with 4, and it is same as 4 by 2. So here, without doing b by a, I am doing what? I am multiplying a inverse into b. Okay, if now a inverse is not a 1 by a. Just you think of a inverse you get as 1 by a. Think like that, but it's not true, because in matrix division is not possible, because 1 by a means what? It's just like dividing 1 with a, right? So in matrix division is not possible. So basically we have to multiply with a inverse. So here, so now the whole question is what? Now you see, I need to find x. So I know the value of b, because b is the constant matrix. I know the value, but this a inverse I don't know. I know a, but a inverse I don't know. So now we have to find the value of a inverse. So once I find the value of a inverse and the value of b, if I multiply these two, then we can easily find the value of x. Achha, I will show you one example. So suppose we are dealing with this thing, 2x plus 3y is equal to 5, 3x plus 4y is equal to 7. These two equations we were dealing with. So if I have to write it in matrix form, the coefficient of x and y are what? So this is my first equation, and this is my second equation. So from the first equation, the matrix A will become what? Coefficient matrix will be what? 2, 3, 2, 3, 3, 4, 3, 4. This is my coefficient matrix. Then variable matrix will be what? Variable matrix will be x and y. They are two variables. And then constant matrix will be what? It will be 5 and 7. If you look at these three matrices, the values of A is given, values of B is given, but values of X is not given. That's why we need to find the matrix X. So the matrix can be expressed as AX is equal to B. AX is equal to B. So A is your 2, 3, 3, 4, X, Y, and that is equal to 5 7. So that's what we get. So we need to find the x inverse. So x is equal to what? This x, a, I will take that side, so it becomes a inverse b. So basically we need to find the inverse of a, or we need to find the inverse of this matrix 2 3 3 4. We have to find inverse of this matrix. So let us see which method we are going to use to find the inverse of that matrix. How to find that? So in order to find A inverse, first thing we need to do is we need to create an augmented matrix. Now what is that augmented matrix? The augmented matrix must be constructed given by like this. So first what you're going to do is, first you're going to write the coefficient, the elements of matrix A, then you put a slash and you write the identity matrix of order 2, 1 0 0 1. It's an identity matrix of order 2. So what I'm saying is that first you form the augmented matrix. So here the augmented matrix will be what? The elements of A is what? 2 3 3 4, then slash 1 0 0 1. That's your augmented matrix. That's how we form augmented matrix. Then after forming augmented matrix, what we're going to do, then by elementary row operations, the augmented matrix will be transformed into this. So by doing elementary row operations, which we haven't learned yet, which we will learn after this lesson, the augmented matrix will be transformed into this. So what we're going to do is we are going to transform this matrix into this one. That is, in place of a1 b1 a2 b2, I'm going to write 1 0 0 1. Then the same operation we will do in the right hand side. So 1 0 0 1 will be transformed into a1 dash b1 dash a2 dash b2 dash, and the A inverse is nothing but a1 dash b1 dash a2 dash b2 dash. So that's how we get the value of A inverse. So what we have to do, by elementary row operations, we have to transform the augmented matrix into this matrix. So basically if I have to I need to transform this one into what? So this one I need to transform into 1 0 0 1 into the inverse of this matrix will come out. Suppose let me just, for the moment I'm writing this one, a2 dash b2 dash, this one is b1 dash. So this is how we form the transformation. I will just 2 3 3 4 I have to transform by elementary row operation to 1 0 0 1, and this side will be transformed into this, and this one, that is a1 dash b1 dash a2 dash b2 dash, this will become your A inverse. This value will give your A inverse. So that's how we find A inverse. So now we're going to learn about elementary row operations. So what are the different elementary row operations are there? So basically there are 6 operations. Now we know that there are 3 columns and 3 rows. We have 3 columns and 3 rows. So that's why it means 6 operations. 6 operations are there for the columns and rows, but we're gonna do with only rows. Columns we are not gonna do. We will just be doing operations for rows. So first thing is what? This is the common one, that is interchange any 2 rows or columns. So we're gonna interchange any 2 rows or columns. So since we're gonna learn only about rows, so we're gonna discuss about rows only. So what we are doing in here, the operation is what? Interchange 2 rows. So applying R1 with R2. So I'm going to interchange R1 with R2. I'm going to interchange with R1 with R2. So here, suppose we have a matrix A. This one is my matrix A, 1 2 3 4. Now if I interchange R1 with R2, what happens? My R1 is what? My R1, this one is my R1, and this one is my R2. This is my R1, this is my R2. So if I interchange, basically means what? The position of R1 and R2 elements will switch. So R2 will go up 3 4 and R1 will come down 1 2. So this is how we interchange. Interchange operations is done like this. So I am interchanging 2 rows. Column operations you don't need to do. So when you are finding a row, or when you are finding A inverse, if you are doing one set of operation, you have to do that set of operations only. You cannot switch another operation. If you are doing row operation, you have to do row operation all the time. You cannot do column operation all of a sudden after doing row. So we have to interchange two rows. Like this way we're gonna do. This is my first operation of matrix. Now the second operation. The second operation says that multiplication of the elements of any row or column by a non-zero number. So here what we're going to do, or what we're doing is, we are multiplying any elements of any row with a non-zero constant. So it means that here, suppose we have a matrix 1 2 3 4 and we are doing this row operation, R1 implies 5R1. Doing this row operation, R1 implies 5R1. So what we are doing, we are multiplying the elements of R1 with 5. Multiplying the elements of R1 with 5. Okay, I made a mistake in here. It won't be 15 and 20. So here it will be what? 5 and 10. By multiplying the elements of R1 with 5, and here it will be 3 and 4. This will be your matrix. This is wrong. It will be 3 and this one will be 4. So this is how we get second operation. So suppose we have a matrix 2 3 4 3. Now what I'm going to do is, I will do an operation R2. R2 implies R2 into 1 by 4. I am multiplying 1 by 4 with the elements of R2. So R1 elements will remain same, they will not change. So, but R2 elements will be what? 4 into 1 by 4 is 1. 3 into 1 by 4 is 3 by 4. This is what we have the matrix after doing the operation number 2. By multiplying each row, by multiplying the elements of any particular row or column with a non-zero constant. Why it says non-zero? If I take a 0, if I multiply with 0, then there is no point in it, because if I multiply with 0, we get 0 0 0 0. The entire thing becomes 0. So we cannot multiply with 0. You have to keep this in mind. We can never multiply with 0. We will always multiply with a non-zero number. Now we have the third and the last operation of a matrix. So the third operation says addition to the elements of ith row, the corresponding elements of the jth row multiplied by k. I know it's too much complicated. Just look at the operation. The operation says what? Suppose we have I pick one row Ri, then I am doing what? I am adding the elements of Ri with multiplying k with this another elements of row. So suppose we are doing one operation. This is my matrix A, 1 2 3 4. So my operation is what? I am doing what? R1 implies R1 plus 2R2. R1 plus 2R2. This is my operation. So what we are doing? I am changing the elements of R1 by doing this operation, by adding the elements of R1 with 2 multiplied with the elements of R2. So here we have 1 2 3 4. So if I ask you what are the elements of R1 in here, 1 2, they are the elements of R1. So basically we are changing the elements of R1. So when I am writing this thing, it means that we are changing the elements of R1. We are not doing anything with the elements of R2. So if we are not doing anything with the elements of R2, then the elements of R2 will remain fixed. We are doing nothing with R2. So here, even here you see, so look at here, R1 implies 5R1. So we are changing the elements of R1, but we are not doing anything with R2. That's why R2 elements remain fixed. Okay, but in here you see we are interchanging R1 and R2, so both of them will change. So then what happens to R1? So what happens to R1? So what you're going to do, what is the element of R1 in here? R1 element, first element of R1 is what? It is 1. So I'm going to write 1 in here plus 2 into, now what is the corresponding element of R2? Corresponding element means what? This one is the first element of R1 and the first element of R2 is what? It is 3. That is what the corresponding element of 1. So we're going to write here 3. So 1 plus 2 into 3, that is 1 plus 6 is 7. So you get the first element of R1 as 7. So we transformed that element of R1 from 1 to 7 by doing this operation. Then what we are going to do is, we have the second element of R1 is 2. The second element of R1 is 2. 2 plus 2 into, and the corresponding element of R2 is 4. So this one will be 10. So we have here 10. So this is how we get by doing this operation. R1 implies R1 plus 2R2. Achha, let me just show you another operation in here fast. So suppose we have a matrix 2 4 6 8. Now I'm going to do one operation. Suppose I'm doing R2 implies R2 minus 2R1. I'm doing this operation. So let's see what happens. So by doing this operation, R1 elements will remain fixed because I'm not doing anything with R1. So R1 elements will be 2 4. R1 elements is fixed. Now what happens to the R2 elements? So R2 elements will be what? So what you're going to do is write this operation in the rough. Write this operation in the rough. Then the first element of R2 is what? The first element of R2 is 6. So I'm going to write here 6 minus 2 into, and the corresponding element of 6 is what? Corresponding element is, first element of R2 is 6. First element of R1 is what? 2. So I'm going to write here 2. So 6 minus 4, that is 2. Then what we have? Then the next second element of R2 is what? 8. So 8 minus 2 into, the second element of R1 is 4. 4. So you get as 8 minus 8, 0. So this is how we get the matrix after doing the third elementary operations of a matrix. So these are the three row operations which we have, and using these row operations we're going to transform the augmented matrix into this form, and then we will get the A inverse. So now we're going to do some problems in here. Let's start with question number 1. 2x minus y is equal to 5 and x plus y is equal to 4. So we have to solve this linear equation, system of linear equations. So basically we need to find the value of x and y. So I told you first thing, when you see this two linear equations, first we need to define those three matrices. So we're going to write here, let A is equal to, A will be what? The coefficients. So here the coefficient of x is what? 2. Coefficient basically means what? What number is multiplied with the variable. So here, what is the number multiplied with y? The number which is, it doesn't show in there, but since it doesn't show, it means minus y, minus 1 is multiplied with y. That's why it becomes minus y. So here I'm going to write minus 1. Now x, what is multiplied with x? 1 is multiplied with x. Some of you will say 0. 0, if x is multiplied with 0, it will entirely become 0. 1 is multiplied with x, because 1 into x is x. So we get 1. Then y, this one is also 1. So this is my A. Then the variable matrix will be what? Variable matrix will be xy, because there are two variables. And then constant matrix will be 5 and 4. This is my constant matrix. So what we are going to do is, we're going to write in matrix form. So by matrix method, Ax is equal to B. So this is what we have in matrix method. We're going to write here. So what is my A? 2 minus 1, 1, 1, and xy is equal to 5, 4. So by matrix method we get this thing. We express the system of linear equations in this form. Now we need to find what? We need to find x. Therefore x is equal to what? A inverse B. Now we learn that x is equal to A inverse B. So we need to find A inverse. So right here, to find A inverse, the augmented matrix, the augmented matrix is given by, now what does this augmented matrix given by? How can I write? So first you can write the elements of A, that is 2 minus 1, 1, 1, and then it will be slash 1, 0, 0, 1. This is your augmented matrix. So now by doing elementary operations we need to convert in what form I will tell you now. So basically you don't have to think about everything. What you're going to do is, so you have to think of operations by which you have to convert this matrix, you have to convert this portion, that is 2 minus 1, 1, 1, into 1 0 0 1. You have to convert that 2 minus 1 1 1 into 1 0 0 1. That's what you have to do. Now whatever operations you use to convert this 2 minus 1 1 1 into this thing, the same operations we are going to do with this side also. The same operations we are going to do with this side. And then what happens, that when the moment this one get transformed into 1 0 1 0 1, the same moment this matrix will give us A inverse. This matrix will give us A inverse. So let us try to solve in here. So we have what? 2 minus 1 1 1 1. So in the graph you just write 1 0 0 1. So first thing, you pick the first element. The first element is 2. So I need to transform this 2 into 1. How can I make this 2 into 1? I need to make this 2 into 1. So basically, if I say, how can I make 5? How can I transform 5 into 1? So just multiply 5 into 1 by 5. So this 5 gets cancelled, we get 1. So in here, if you have 2 in here, so I will multiply it with 1 by 2. So since I am multiplying 1 by 2, so I am multiplying 1 by 2 with what? R1, because it is R1 element. So my operation will be R1 implies 2 into R1. It will be R1 implies, not 2 into R1, it will be half into R1. Half into R1, because I am going to make it 1. So half into R1. So it will become what? So it will become 2 into half minus 1 into half. Same operation we're going to do it in here. 1 into half, 0 into half, and the R2 element will remain fixed. This is my R2. We are doing nothing with R2. R2 will remain fixed. So we have here 0 1. So this is what we get. Now the next operation will be what? So let me write this nicely. 1 minus half, 1 1, half, 0 0 1. So next operation what we have is, you see, the next one, you think of this one, that is 0. Now after you finish with 1, you see the below one is what? 0. So 0, it means I need to make this one 0. How can I make this one 0? Now always remember, in order to make an element 1, you just multiply it with its reciprocal. Let me just write in here. To make an element 1, multiply with reciprocal. Now the second one is to make an element 0. We have to take the help of another row. So we have to take the help of another row to make an element 0. If I have to make an element 1, we just have to multiply it with a reciprocal. So here I needed to make this element 1, so I have multiplied this 2 with its reciprocal, that is half. But here I need to make this element 0. So in order to make this element 0, we have to take the help of the another row. So what we are going to do? So the another row element is what? 1. And here this element is what? 1. So how can I make this 0? Just subtract them. If I subtract them, so my operation will be R2. This element is what? R2. So I want to make the element of R2 0. So R2 implies R2 minus R1. This is what we get. So let us do this operation. So we have 1 minus 1. R1 element will remain fixed. There will be no change in R1 because we are not doing any operation in R1. So R2 element is 1. So 1 minus 1 is 0. 1 minus 1 is 0. Now the second element of R2, look at here, the second element is 1. So 1 minus of the corresponding element of R1. So 1 minus of minus half. So 1 plus half, that is 3 by 2. So here it will be 3 by 2. Okay. Now the second one, Now this side, so we are doing what? R2 minus R1. So 0 minus half, that is minus half. 1 minus 0, 1. This is what we get by doing this operation. R2 implies R2 minus R1. Now what we have, so we got 1 0 we got. Now the next step is we need to get what? So this is what we need to get. The 1 0 we already got. The next step we need to get what? This element as 1. So first this one, then this is my first step, this is my second step, this is my third step, and ultimately this is my fourth step. So my third step is what? To get this one 1. So it means we have to get this one 1. So how can I get this one 1? That is the element of R2. That is the element of R2. So how can I get 1? I already told you, to make an element 1 we have to multiply with its reciprocal. So 3 by 2, what is the opposite of 3 by 2? It is 2 by 3. So we have to multiply with R2 2 by 3 into R2, the reciprocal of 3 by 2. So if I multiply with 2 by 3, what do we get? So we have 1 minus half 0 into, let me just write it nicely, 0 into 2 by 3, then 3 by 2 into 2 by 3, then we have half. The same operations we're going to do other side, minus half into 2 by 3, then 1 into 2 by 3. This is what we have. So what do we get in here? So we get 1 minus half 0, and this one is coming out to be 1, and here we have half 0, this 2 gets cancelled, minus 1 by 3, and we get 2 by 3. This is what we have. Now ultimately we have the last term, this one, and this one minus half we have to make what? 0. I need to make minus half as 0. Now how can I make it 0? Using the help of another row, other row. So think of how can I make this minus half as 0 using this 1, using this 1. So basically we know that if I have minus 1, if I add half with it, then we get 0. If I add half with it, then we get 0. But we cannot add half. We cannot add half just like that. You know what we can do is, this half we can multiply it with 1, half into 1. So minus half plus half into 1 we can do. So basically what I am trying to say is, the operation will be R1 implies, because R1 element, minus half is an R1 element, R1 plus half R2. This is what we do. This is how the operation will be. Operations cannot be like this. R1 implies R1 plus half. This is not the operation. You have to take the help of another row. You see now that it will become 0. So what is the element of R1? It is minus half plus half. And what is the element of R2? The element of R2 is 1. You see, minus half plus half. Now it's become 0. So that's how we do operations. So what we have? So the first element here is what? 1. Now you see 1 plus half into, what do you have? R2 element is what? Corresponding is 0. 0. Then minus half plus half into 1, and the R2 elements will remain fixed. This side same thing. So half plus half into corresponding element of R2 is minus 1 by 3, minus 1 by 3, and plus, not plus, 0 plus half into 2 by 3, and the R2 element will remain fixed. So let's see what do we get. So we have 1, this one is 0, 0, 1. Now you see we have already got the identity matrix. And this side what we have is half minus 1 by 6 minus 1 by 3. This one is coming out to be, this 2 gets cancelled. So we have 1 by 3, and here we have 2 by 3. Yeah, so let us write it nicely. 1 0 0 1. So 1 by 2 minus 1 by 6, if we take LCM, we get, it's coming out to be 1 by 3. So 1 by 3, 1 by 3, minus 1 by 3, 2 by 3. So by looking at it, we can directly say therefore A inverse, inverse is called, this is the matrix of A inverse. So we have 1 by 3, 1 by 3, minus 1 by 3, 2 by 3. That's my A inverse. But we don't stop here. We found out A inverse, but the main point is what? We need to find the value of x. So my x was equal to what? X was equal to A inverse B. So I'm going to write here A inverse in here. So you get 1 by 3, 1 by 3, minus 1 by 3, 2 by 3. That's my A inverse. And what is my B? My B is, this is my B, 5, 4. This is my B, 5, 4. Now you just multiply these terms. Just multiply the terms. So what do you get? If I do normal matrix multiplication, we have 1 by 3 into 5, 1 by 3 into 5, this one with this one. So this one with this one, we have 5 by 3. Once again, 5 by 3 plus 4 by 3. And then the next one, minus 5 by 3, minus 5 by 3 plus 8 by 3. So let's do this one fast. X, Y. So that gives us our, we are getting 9 by 3 in here, and in the denominator we get 3 by 3. So basically we are getting 3 and 1. So therefore x is equal to 3 and y is equal to 1. So this is how we find the values of x is equal to 3 and y is equal to 1. So I hope it's clear. Achha, let me just do the second question. Now second question is, one second. So second question what we have is x plus 3y is equal to 5 and 2x plus 6y is equal to x. Now how are we going to do this one? So same way we're going to write here, we're going to define the three matrices. So we're going to do here, let A is equal to, so A will be equal to 1, 3, 2, 6, the coefficients. Then x is equal to the variable matrix x, y, and B will be equal to 5 and 8. This is what we have: the constant matrix, variable matrix, and coefficient matrix. So by matrix method what we're going to write is, by matrix method Ax is equal to B. So we have 1, 3, 2, 6. X is what? X, Y, and that is equal to 5 and 8. This is what we have by matrix method. Now, but we need to find what? X. Therefore, X is equal to A inverse B. So we need to find A inverse. So to find A inverse, the augmented matrix is given by, what does this augmented matrix is given by? Wait a second. So it is given by 1, 3, 2, 6, then 1, 0, 0, 1. So this is my augmented matrix. Now we have to transform this. I told you by elementary row operations we have to transform this 1, 3, 2, 6 into 1, 0, 0, 1. So if I look at here, I told you what, this is my first, this is my second, this is my third, this is my fourth. This way I will go. So my first is 1 and it's already 1, so we don't need to do the first one. It's already 1 in there, so it's good that my work is reduced. Now after the first one we'll check the second one. The second one is what? 0. Second one is 0. So here this is 2. So in order to make this 0, I need to take the help of this another row. So this is my R1, this is my R2. So in order to make this 2 0, I need to take the help of R1. So how can I basically, how do I make 2 0? By 2 minus 2, by doing this thing. But what I'm going to do is I'm just multiply 2 into 1 in here, 2 into 1. So what do I get? The operation will be R2 implies R2 minus 2 R1. You see, the R2 element is what? 2 minus 2 into R1 element is what? 1. That's why I'm multiplying 1 in here. This 1 is nothing but the R1 element. So this is the operation we're going to do. So the operation becomes what? R1 element will remain fixed. So R2 element will become what? So we get 2. Look at here. The R2 element is what? 2 minus 2 into R1 element is what? 1. This is what we have. Now the next one is what? R2 element is what? 6. 6 minus 2 into R1 element is what? 3. 2 into 3. This is what we have. So now the next one, here the same thing we're going to do is here R2 element is what? 0. 0 minus 2 into R1. 2 into R1 element is what? 1. And the next one is what? 1 minus 2 into R1 element is what? 0. You write here 0. So let me just write it nicely. Here I'm going to write 0. Yeah. So what do we get? We get 1, 3. This one is coming 2 minus 2, that is 0. This one is coming 6 minus 6. This question, it won't be possible because this one is also coming 0. This one is also coming 0. So for this question we can directly write is that inverse is not possible. Inverse is not possible for these type of questions. So here whenever you see that both the elements are becoming 0, by both the elements are becoming 0, say A inverse does not exist. A inverse does not exist 0. Does not exist because all the two elements of R2 become 0. So A inverse does not exist. We're going to write like that. And since A inverse does not exist, so no solution. So here we cannot find any values of x and y. So we have no solution. So that's how we learned how to find system of linear equations.